So today we have another related rates problem, and it says a kite 50 meters above the ground. So here's my kite, and it's 50 meters above the ground, denoted by y. And they say that this kite moves horizontally at a speed of 2 meters a second. So if my horizontal is denoted by x, I can say, well, x is changing with respect to time. At 2 meters every second. So before we get into the next statement, I want to explain what r and what theta is. So let me get another line in here. And let's say this is another piece of string. So if r is my string and this kite is moving horizontally, they want to know at what rate is this angle decreasing as the kite is moving horizontally. So as you can see, as I let out more string, that angle theta is decreasing on my triangle. So can you see that? Okay. And they want to know at what rate it's decreasing when I let out exactly 100 meters of string. So that's a second. So we want d theta by dt when 100 meters of string has been let out. And let me put that in a box because this is important. Okay, and this is a right angle triangle. Okay, so let's find a trigonometric function which relates x, y, and theta. And the reason why I want to relate these three things, well, firstly, the angle, because they want d theta by dt. So if I take the derivative, I want to get d theta by dt in my equation. Secondly, it's given that dx by dt is 2 meters a second. So again, if I want to get dx by dt in my equation and sub in 2, well, I'm going to want to have x in my original equation. And the reason why I'm using y, well, because 50 is going to stay constant because they tell me it's 50 meters above the ground and it's moving horizontally, so this kite is not going to go any higher or any lower. So let's say, well, I'm just going to say, well, theta is equal to, I'm going to put x on the top, and I'm going to have 50 on my denominator. So let's find a trigonometric function that relates these three things. So if I think about SOHCAHTOA, the tangent of theta is going to be opposite over adjacent. So if I take the reciprocal of this function, I get, well, cotangent theta is going to be x over 50. Okay, so I can say that this is just going to be cotangent. So let's take the derivative of both sides with respect to time. So d by dt of cotangent theta is going to be equal to d by dt of x over 50. Okay, so on the left hand side, I'm going to have, this is going to be minus cosecant squared theta multiplied by the derivative of theta with respect to time is going to be d theta by dt. Okay. So on the right hand side, I'm just gonna do the quotient rule. So by taking the derivative with respect to time, I'm gonna have the bottom function multiplied by the derivative of x with respect to time, which is dx by dt, and by quotient rule, so I'm gonna minus. So the derivative of the bottom function is just 0 multiplied by x, which is the top function, and this whole thing is going to be 0, so I don't have to write that, and this is going to be all over the bottom function squared. So in the next step, I'm gonna realize that 50 squared is just 50 times 50, and I can just cancel one out. So let me just erase this, and if I cancel one out, I'm gonna get minus cosecant squared theta is gonna be, okay, my bad, that's gonna be multiplied by d theta by dt is gonna be equal to dx by dt all over 50. So in the next step, what I'm gonna do is divide both sides by minus cosecant squared theta to cancel these out, and get d theta by dt alone. So if I do that, I'll have d theta by dt is going to be equal to, I'm going to substitute in dx by dt, which is 2 meters a second, and I'm going to have 2 over 50 divided by minus cosecant squared theta. So let's think about cosecant. If I take the reciprocal of cosecant, I'll have sine theta, and by SOHCAHTOA, sine theta is going to be the opposite over the hypotenuse. So taking the reciprocal of that, I will get cosecant is r over 50. So this is going to be equal to 2 over 50 divided by, that's minus r over 50 all squared. Okay, so let's square r over 50, and if I do that, let's copy down 2 over 50 divided by, it's going to be minus r squared all over 50 squared, and taking the reciprocal of that so that I can change that to multiplication, that's going to be into minus, that's going to change to 50 squared all over r squared. So let's simplify this. This is going to be 2 times 50 squared all over 50 times r squared, and let's not forget the minus. Let's cancel out 150. 2 times 50 is going to be 100. And if we think about r squared, well, they want to know d theta by dt when 100 meters of string has been let out, and r is our string, so we can substitute in 100 squared, cancel out 100, and we get that d theta by dt is decreasing at -1 all over 100. And if we want to convert this into radians, this is going to be minus 0.01 radians, and they say every second. So at what rate is the angle between the string and the horizontal decreasing when 100 meters of string has been let out? Well, the angle is decreasing at minus 0.01 radians every second.